Hey y'all, it's me, Miss B, and today we are using exponential application. And we've already covered exponential functions. Here are the two equations that we've previously covered, and if you need to go over what each of those values are, you can go ahead. Just remember that t minus t naught and x, x is used when we have just the amount of times thing is repeated, it's given, and then t minus t naught is when we're given 2 times. Exponential growth is when we have a b value right here that is greater than 1. And here's what the graph will look like. It'll look something like this. And of course it'll extend this way as well. And then exponential decay is when b is between 0 and 1, and it's decreasing like this. Okay. Then E, now we're going to talk about E. E is a natural base. It's irrational, and it's just like pi. If you type it into your calculator, E, you get that E is equal to 2.7182 and so on. But we will just write it as 2.72, about, round to the nearest tenth. Okay, it can be called Euler's number or Napier's constant. Most of the time you'll just hear it as E. Okay, so here we have a real life application. It says coronavirus has been growing at an exponential rate. Someone calculated the growth rate is 0.112. If the function for the number of people infected with coronavirus is 1.565 e to the 0.112x, where x is the number of days, then let's answer these questions below. So if I have 10 days, it's looking for day 10, then x is equal to 10. So I'm going to plug 10 into my equation. I have I'll put y equals 1.565 e to the 0.112 times 10. Okay, plug that into our calculator. We have 1.565 e to the, to the 112 times, and we have to actually put this in parentheses, otherwise it will not let us multiply, times, 10, close our parenthesis, we get 4.79. So at the beginning, we only have about 5 people who are infected. Not too bad. 5 people, not so bad. All right, let's look after 3 weeks. So 3 weeks, let's calculate the number of days though. So 3 weeks is going to be, to find our x, we're going to have to take 3 times the number of days in a week, 7, so x is equal to 21. So there's our 10 there. So we're going to have y equals 1.565 e to 0.112 times 21. All right, what I do when I plug this in is I go to my calculator, I go to the 10, and I just back it up and type 21. That way I don't have to type out the whole thing again. And I get 16.4. So we have about 16 people infected. All right, then let's look after 2 months. So 2 months, let's say, let's just do 2 months together. So we'll say March plus April. March has 30 days. April has, let me put this in blue. So let's do X equals March plus April, which is 31 plus 30, which is 61 days. So we'll plug that in. Y equals 1.565 e to 0.112 times 61. So change this out. Put a 61 in here. We get 1,451 people Okay, so you can see that we are making quite a large jump. So from here to here, that's about double the time. It doesn't seem like that many people, but then after 2 months, which is not that much time, we have 1,000 people who are infected. And then let's go ahead and put 365 in there because it's been about a year of this. And we've got like millions of people have this. So that's a really large number of people. I'm actually going to go ahead and write that down. So so just a note here, just for interest, after 365 days, it was 8.9 to the times 10 to the 17th. So that means it has 17 zeros. So this is what this number would look like. 8, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that is how many people? So that's 1,000, a million, a billion, a trillion, a quadrillion, a quintillion. So we've got a lot of people with coronavirus. Obviously, this isn't quite true anymore because of the fact that we did flatten the curve by wearing masks and stuff like that. So by wearing our masks and staying inside, we really reduced the amount of people that got coronavirus. Okay, so compound interest is really important. We're moving on to interest here. Another reason why exponential growth and decay is so important is because of the fact that it deals with money. So go ahead and get this copied down. This equation right here is used when we have a number of compounding periods. We also have this thing called continuous compounding, and you'll know when you have what because it'll say, but you have 2 different equations for the different types. R is the interest rate written as a decimal. N is the number of compounding periods in a year. T is the number of years. P is the principal or initial amount. We can also call it A sub 0 or A naught. And then A is our account balance. So here's our first example. If you deposit $6,500 into an account paying 8% annual interest compounded monthly, how much will you have after 7 years? So we've got 8% interest, $6,500, and it's compounded monthly. And after 7 years, how much are we going to have? So we're going to use this equation right here. I'm going to go ahead and write these off to the side. So this is what I do. I just write out P, R, N, T, and then I fill those in. So P is my principal amount, or my starting amount. It's going to be 6,500. R is my rate, but I have to write it as a decimal. So that as a decimal is 0.08. compounded monthly. So n is the number of compounding periods in a year, and there are 12 months in a year. So this right here is 12. And then t is 7 because that's the amount of years we have. So we just plug it in. So we get that a equals 6,500 times 1 plus 0.08 divided by 12 times 12 times 7 to the 12 times 7. So go ahead and type that in. 6,500 times 1 plus 0.08 divided by 12 to the, got to put parentheses up here, 12 times 7. So we get 11,358.24. So 11,358.24. Okay, so that's how much money I have after 7 years, which is a good chunk of change. So this is, and we do want to write that as dollars because that is, we are talking about money here. Okay. It says Xing puts $800 into an account to use for school expenses. The account earns 14% interest compounded continuously. How much will be in the account after 5 years? And I'm going to go ahead and highlight $800. All right, so this one, since we're compounding continuously, we're going to use the equation P e to the r t. I always remember it's PERT. A lot of people do. So I'm going to go ahead and write P, R, and T over here so I can fill those out. So go ahead and fill those out yourself. Should have said P was 800, R as a decimal is 0.14, and the amount of time is 5 years. Go ahead and plug those into this equation. What you should have got was A equals 800 e to the 0.14 times t. And then go ahead and plug that into a calculator. What you should have got is, if we type that in, 800e to the 0.14 times 5, times 5, gives me $1,611.00. We do want to label that as money. So make sure, just make a little note, don't forget to label.